but we're not going to waste any more time because our distinguished speaker has things to do. So we're going to pass the baton to Ken Rainey, AEAC, and I made a typo, Ken. Sorry about that. Alpha Charlie 5 EZ. He's been handing off and on since 1967. After a tour in Vietnam, he was assigned to the 4th Area Army Mars Station, worked as A5 USA running HF phone patches for service members in Vietnam, Thailand, Laos, and Cambodia. Ken has over 20 years in the telecommunications industry. He, I'm trying to read all the scratch. He teaches Morse code at the CW Academy and is a member of LARC and the Denton County Amateur Radio Association. Sorry about stumbling through all that, Ken. And so we are very happy to have Ken here with us. Again, Alpha Charlie 5 Echo Zulu. And we're going to listen to Bonding and Grounding Inside Your Shack. Ken, go ahead and take it away.
All right, David. Can everybody hear me okay? Audio good? Okay. Well, a couple of things I forgot to put in the little bio. You know, it's almost kind of like a little homecoming. I actually was a member of Mars back in the 90s, probably up in about 95 through about 2001, 2002. When I finally retired from Verizon, and my wife packed the house and got the motor coach and traveled for a couple of years, and then we finally replanted up here in Oak Point, just way north of Little Elm. So I'm somewhat familiar with the Mars Club. Of course, you got a couple. You got Dale Hyatt and Bob Norris, which also belong to the LARC Amateur Club up in the Colony, which is really close to me. That's why I go there. Well, let me get into this presentation. Probably some of the older guys probably have seen this presentation before. We have given this presentation in a more extended version to, we did it in HamCom 2019. We've done it for a lot of clubs around. And it's got some good information. Now, if you've been hamming for quite a while, probably this information may be a little redundant to you, but maybe we'll pick out a couple of things that you hadn't really thought about in your grounding, and we're gonna kind of go through this in a kind of a logical order. We're going to kind of show you how everything kind of connects and how to keep yourself safe, and how to get your amateur equipment to work properly. So without any more fanfare, let me just start stepping through here. Let me see if I get the keyboard to wake up. Okay, we're going to talk a little bit about electrical safety. I may have to close the door. My little Poochie may want to interfere. Let me close the door. We're going to talk a little bit about electrical safety, bonding and grounding in the ham shack. That's where a lot of us spend most of our radio time, is in the ham shack. So we're just going to kind of go through this and kind of enlighten you with some interesting facts. Okay, we're gonna do this in a very brief look of how the NEC and amateur radio, how they work together. We're going to discuss grounding versus bonding. We're going to talk a little bit about electrical safety ground. And we're going to talk a little bit about chassis ground, or sometimes referred to as RF ground. And we're going to talk about single point grounding. Now, see, we got 4 different topics right there that we're going to cover tonight. And as with amateur radio is an evolving hobby. And I've been in this hobby off and on since probably 1964. And one thing that amateurs should never stop learning. It's a growing hobby. There's lots to do, many things to learn. So never stop learning. Well, as always, when you start talking about electronics and amateur radio and all, safety is always one of the big factors. And like always, amateur is not a dangerous hobby, but you just need to pay attention to be informed with what you're doing, especially raising antennas and when you're talking about grounding and all. So just remember, be safe, have the proper attitude, and plan carefully. As the little guy says, don't want to turn into a skeleton. Okay, well, let's take a little quiz before we get started. You don't have to answer this. You don't have to write it down. Just kind of in the back of your mind, just kind of think about these questions. What does the NEC stand for? And who or what is the AHJ? What does the term single point grounding mean? Is it safe to have a separate ground for your ham shack? Does your TV flicker every time you key your transmitter? If your wife is watching Wheel of Fortune and you get on the radio and you key down and all of a sudden she missed that important clue, does she throw things at you? Is bonding different from grounding? Should all antennas be grounded? Here's a good one. And is it okay to connect all of your grounds to your house ground? And does that microphone bite you every time you transmit? Do you get that little nasty RF shock, that little tingle when you touch it to your micro or to your lips? And does your TV go crazy or your SWR meter go crazy with funny readings when you transmit? Do you get RF shock when you touch metallic objects? And when transmitting, is there distorted audio in your PC speaker? And finally, do you get fluorescent light flicker? Anyway, these are just some topics that we're going to cover tonight. It just kind of give you a clue as to where we're going. Well, let's apply the NEC to amateur radio. Now, this book is probably about 700 pages, give or take. They update it about every 2 or 3 years, and they'll make changes to it, but it's about 700 pages. Now, the NEC is not written for the layman. This is written for the journeyman and the apprentices that are learning to be technicians and all. This is kind of like their study book. This is what they learn, and is not meant for you and I to be able to read this book. They have written it in such a way that it's more for the electrical trade, so to speak. So the national or NEC or the National Electrical Code is not intended to be to help you make your system better unless it directly affects safety. Now, this is the important part of the NEC. They're only concerned with safety. Okay, part 90.1, practical safeguarding. The code is the practical safeguarding of persons and property for hazardous risk arising from electricity, basically. And the adequacy, the code contains provisions that are considered necessary for safety, compliance with proper maintenance results in an installation that is essentially free from hazard. But they don't care if it works or not, as long as your equipment is grounded and there's no electricity that you could get shocked. In other words, the national code is designed for safety, safety, safety. They don't care if it works or not. And the intent of the code is a design specification, and it is not an instruction manual. You can't pick it up and use it as an instruction manual. Now, the NEC has got a whole bunch of chapters in there, and like I said, there's like some 700 pages, but there's really only a few that actually pertain to amateur, so to speak. That's chapter 2, which is wiring and protection, and chapter 8, which is communications. Now, some of it might fall into some of the other categories, but equipment for general use and wiring methods and all like that. Since we don't really do any house wiring, it doesn't really pertain to us. The enforcement. So the code is intended to be used as a mandatory application by government bodies. And we're getting into the old official part now. Now we're getting to the legalese. And and the governing bodies that exercise legal jurisdiction over electrical installations, including signaling and communication systems. That's where we fall in. The code, the authority of having this jurisdiction for enforcement of the code has the responsibility. Now, get this part, they can make interpretations of the rules. In other words, they don't have to follow the rule letter by letter. They can read it and they can make their own interpretation of what they think the rule actually says. Article 810 deals with radio and television, which we kind of fall under the antenna systems and wires, strung like dipoles, infed, OCF, and the Yagyus, and everything that you do outside. And a lot of cities have taken the NEC and have written their own city ordinances. And sometimes they will maybe tweak the ordinance just a little bit, but they always refer back to the National Electrical Code as their basis for what they do. So your city ordinances, NEC, are pretty much the same. Well, the disclaimer and the enforcement, the enforceable or the enforcer of this National Electric, it's almost a tongue twister, is the AHJ. This is the authority having jurisdiction. He has the ability to interpret what the AHJ reads the NEC, and he can interpret what he thinks should be there. And if you call the AHJ to come out and inspect your antenna, who's going to be there? This guy called a building inspector. Now, these building inspectors, 99% of them have about 1% knowledge of RF, unless you live in Louisville. And fortunately, the Denton Club has a member that is a building inspector that is an amateur. So there are a few of them out there that know what they're doing. But if you have to call for an inspection on your tower or something to do with your equipment, you need to make sure that when you call this building inspector, that you have all the answers that he could ever possibly ask. You need to razzle dazzle him with your intelligence is what you need to do, because he's not going to know what you're talking about when you start talking about fall radius and near field and far field when it comes to radiation patterns. He's not going to have a clue what you're talking about. So you be the expert when you call the building inspector. Well, you can go out online and you can actually download this Article 250, which basically covers I'm going to guess all 700 pages have been put in kind of a nutshell spreadsheet, not a spreadsheet, but a sheet that you can print out and you can read it. And it has some of the definitions. Article 100 is definitions, and it goes through and it talks about grounding electrodes and a few other things. So it's got some good information in here, and we're going to cover a lot of this information in our presentation. But this is just kind of like a little mini map of the National Electrical Code. Okay, there's two books. If you don't have any books at all in your library, here are two books that you really should have. Now, this Black & Decker Complete Guide to Wiring, you can pick it up at your local hardware store. You get it from Amazon and all. This tells you everything you would ever want to know about your house wiring. Not that you're going to be, making any changes, but it's a good book to have if you're going to put in another socket, or maybe you've got a 110 outlet and you'd like to convert it to 220. What you have to do as far as wire size, circuit breakers, and the receptacles and all. This is a book that you would want to have. And another one is this one written by Ward Silver. Now, this is a picture of the first edition. There is a second edition out now. So Ward Silver is kind of ironic. When I did this first presentation back in 2019, this book was not out. I think Ward was still in the finishing touches. It hadn't been published and hadn't been circulated yet. And about 6 months after we did this presentation in 2019, this book came out, and I said, interesting. But these are two books that you really should have in your library. Okay, here's a couple of important questions. Do I bond or do I ground? Interesting question. Okay, the term bonding and grounding are often, amateurs use, we're bad about using acronyms and using terms and all. And we tend to use the terms bonding and grounding interchangeably in amateur radio, where in fact they are totally different. Now, if you were to go to Europe and you wanted to talk about bonding, you would find, or maybe I get a little ahead of myself. In fact, bonding and grounding have completely different meanings, and we're going to show you how they're going to be employed in the ham shack. Totally different meanings. Let's take bonding. Let's do the official definition of bonding. According to the NEC, bonding is a method by which all electrically conductive metallic or materials and metallic surfaces, this be your transmitter or your amplifier, not normally intended to be energized. Now, say you don't normally energize your chassis, should be connected together by a low impedance conductive means, a piece of wire, a braided strap, or something like that, to avoid any appreciable potential difference. In other words, don't get shocked if you touch your transmitter and you reach over and you touch your amplifier and you get a little zing in your fingers. They should all be at the same potential. Well, let's look at it in a more practical side. Okay, bonding in a practical side is a method by which all electrically conductive metal surfaces are tied together to avoid a potential shock. That's pretty much it. All right, now you're going to see these three little devices pop up here quite often. This is just a random picking. This ham shack has got an HF transmitter, it's got a VHF, UHF transceiver, and it's got a power supply that supplies energy to those two. So this is going to be our basic building blocks that we're going to use for this presentation. Okay, now in order to satisfy bonding, I'm going to take a wire and I'm going to connect my transceiver to my UHF to my power supply. All these metal boxes are now electrically tied together. They're all now at the same potential, okay? So we have satisfied bonding. Well, let's talk about grounding, the official definition first. Grounding is a term that's used rather loosely in North America. When we say we're going to ground something, that means we're going to attach it to Mother Earth. But if you were to go over to England or to Europe somewhere, they use a term called earthing, 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 instead of grounding. What it is, it's a way of connecting something to Earth. It can be an intentional connection or an unintentional by some associated metallic means intended to be employed as a designated grounding electrode. And we know what a grounding electrode is. Most of us have driven copper rods into the ground. So a grounding electrode, okay? A designated grounding electrode is that device that is intended to establish the direct electrical connection to Earth. Now, a lot of houses built in, I think from about 2000 on, when they wired the houses, they wire your circuit breaker box to either a ground in the slab, or they drive an 8-foot ground rod right at the circuit where your meter is usually. So either you have a wire going back into your foundation, or you have a metal rod out there somewhere. That's how they ground your house. Okay, a commonly designated grounding electrode, as far as amateur is concerned, is often a copper clad or a copper clad steel rod. This is that 4 or 8-foot ground rod that you pick up at Lowe's or Home Depot. And by all means, do not attach your ground to gas pipes or aluminum rods. They should never, never be used. Gas pipes, well, you know what could happen there if you created a spark. Aluminum rods will oxidize and they will present a high impedance resistance to ground, which basically makes them null and void. Okay, grounding on a practical definition. Grounding is attaching a conductive wire to a piece of equipment and then conducting that wire to a ground terminal. Okay. All right. Here's our system again. Here's our three pieces of equipment. Now, bonding says connect all three of these pieces of equipment together with a wire. Okay. I have just satisfied that requirement for bonding. Now to ground, I'm going to connect all three of those to my ground wire. Okay. Well, a lot of us say, well, gee, that's kind of redundant. I don't need those extra wires. Why don't I just get rid of those? And that's okay for right now. Just we're trying to satisfy the definitions. We have satisfied bonding and we have satisfied grounding. So far we're okay. All right. Now we're going to introduce a new piece of equipment, the common household power outlet. And that could be a little two socket plug on the wall, or it could be a power strip, or it could be something that that carries electricity. Now, since our HF transceiver and our UHF VHF usually are DC powered, our power supply has a ground that is connected to the house ground, and it's done through that third wire, or which is connected to the green wire, which goes back to your circuit panel right there, and then it's grounded. I think we're getting somewhere here. All right, let's keep going. Okay, there may be a problem here in Fifth City, but we're going to see if we can resolve it. Okay, let's carry on. As hams, we are concerned with at least 4 types of grounds. Your electrical safety ground, that's your house ground. Your common reference potential, which is your chassis ground. Your internal signal ground, because yes, with digital now, you're going to wind up facing, if you do any circuit building, there are times where you will have a signal ground that is not connected to your chassis ground. It has its own signal return path. And then you've got your lightning or earth ground. These systems are for the most part, are mutually exclusive. In other words, they don't really connect to each other. And you need to design whatever you're doing to make sure that you don't nullify one like a signal ground. If you say, well, I'm going to just take that signal ground to earth ground, you might in fact totally disconnect whatever the circuit was supposed to be doing. And you could you might even damage your equipment. So you need to make sure that your grounding system takes into account all of these different grounds and you don't try to nullify one of them. Our electrical grounding systems, the use of grounding symbols is not always strictly adhered to. What I'm saying is there's not a true definitive standard for markings when you look at a schematic. Most time you will see this system referenced for a safety ground or earth ground. A chassis ground is look like a little 3-pronged rake. An internal ground or a signal ground could be any of these 4. Could be just a black arrow, it could be a white arrow. It could have a little A, which would be an analog ground, or it could have a little D, which would be a digital ground. And then you've got your lightning. Now, a lot of times you will see in some schematics where they will use safety ground as their system ground, which you have to really look at what are they doing. Is it actually a chassis ground, or are they really giving you an earth safety ground? So just remember, these are your 4 basic symbols. And don't forget that good old safety house ground. And you need to fully understand the grounding systems of your house. Every appliance that you have is grounded to your house ground. Be it your toaster, your TV, because they all usually have that 3-prong wire, or if they have a 2-prong, they're polarized. So you know that what the larger diameter connector goes to ground. And those are all connected to your house ground. Okay, power line ground and safety ground is required by your building codes. And this is where the National Electrical comes into play. Is here again, they're concerned with safety of life and property surrounding your electrical systems. So if you look at this green wire, and there's a little picture of it, that's that little prong, a little rounded prong on a 3-prong connector. That goes directly to ground, right through your house wire, right to that ground rod. And this term is what they refer to as the 3rd prong, or the green ground wire. Green wire ground or green ground wire. That is your electrical safety ground. The conductive cases are required to be conducted to a bonding system, which is also connected to earth. And if you don't get things just right, and you got something that's kind of amiss, then this might be you. You might get a little tingle every time you plug something together, or you blow a circuit breaker. Okay, chassis ground, and here's where the common reference potential comes in. Hams for decades have been advised to bond all equipment cabinets to an RF ground. Well, RF ground is a term that was used way back in the 60s, 50s, 40s, way back before all of the solid state and all the new equipment that most of us run now. But actually, what they were referring to was the term of chassis ground. So anytime you see the word RF ground, just mentally remember that what they're talking about is chassis ground. Oh, there's our 3 systems again. Okay, now here we go. Okay, here's our HF transceiver, our VHF transceiver, and our power supply. And this is your RF, or your chassis ground, that green line there, connected to a ground rod. And then there comes your house ground. And look ahead. Okay, here we go. There's something amiss in Fifth City, so to speak, because what's happening now, we now have 2 grounds. We have your house ground, and we've got your equipment, or where all of your amateur equipment is connected to, and that's what we're using as our chassis ground, which everything goes to ground, right? Well, the problem is right here. This is where the problem is, because these 2 grounds, there could actually be a voltage difference between these 2 points, and this would generate a voltage, and voltages and current produces shock. Okay, in a perfect world, this is chassis ground in a perfect world. And you've probably seen this picture before, where everything is tied to one point. And they say, oh, you've got to put everything together. It's got to all come back to one central point, and then that point has to be taken to ground. Well, that is great if you live in a perfect world. But most of us live in a more practical world, and our equipment might be 4 or 5 feet apart, or it might be on a shelf. Every shack is different, and sometimes we don't have the luxury of having everything tied to a central point. So what we do is we compromise, we improvise. But depending on the runs that you make, you may have a problem, because when we take those 2 things out, we could create what's called a possible ground loop. And the reason being is there's actually resistance between these 2 points. Now, it might be a 0.000001 ohm. It may be very small, and it probably is, because wire is measured in resistance per 1,000 feet. And you're talking about 5 or 6 feet. But as a general rule, this doesn't always cause a problem. In a perfect world, in a way they like to define it, they say this causes problems. Well, I'm going to show you ways of getting around this and still not be grounded to a single point as we go through here. Okay, RF grounding and bonding the system. The RF ground is an old term Well, this I've already told you about this. The problem is back in the old days where most of the antennas were long wire, they would use the ground as their return for their antenna. And in some cases, the ground is actually part of the antenna. But you have to be careful in attaching that ground to your chassis ground or to your earth ground is you got to remember you don't want to create resistance between points. And if you design your system to create this common reference potential or a reference plane, you won't have that problem. So connecting your your ground on your antenna to your house ground is not a good idea. Because the whole purpose of all these grounding is to try to minimize the RF current that could flow between pieces of equipment in your house wiring. All right. Some hams think that RF ground should be isolated from the safety ground in the house. That is an absolutely not true statement. This is old school thinking. All grounds, now I say all grounds, including safety ground, your chastity ground, your lightning ground, all grounds must be bonded together in order to make one ground point. And this is explained in the NEC. It's a requirement that all systems be grounded to a common reference potential. Okay, let's look at some practical stations that have multiple ground rods spaced far apart is actually a desirable feature. Remember if you've ever decided, well, I need to put 5 or 6 ground rods in the ground, or I need to put one ground rod, or would one ground rod serve for everything? Well, the large surface area or the large surface contact area with the earth helps reduce ground loops. Now, 8-foot copper rods, multiple ground rods bonded together provide the best coverage, and I'll show you why. Okay, all ground rods must be bonded together. And I'm going to keep repeating this until they say if you repeat it 7 times, you'll remember it. But I'm going to repeat this same little thing over and over again. All ground rods must be bonded together. You need to remember to calculate the lengths of your ground runs between your ground rods, because if you get them to be at a perfect harmonic of whatever frequency you're working on, you might get a little radiation in there. Okay, there is what's called the sphere of influence. This is where you have a ground rod, and now the picture is for a 10-foot, but we can modify this for an 8-foot ground rod. What they're saying is if you drive a 10-foot ground rod into the ground, it can cover a 10-foot radius around that ground rod. So now that says from one ground rod, I can go out 10 feet before I start getting any reduction in resistance. And the formula is pretty simple. It's just the velocity. The volume equals 5 times pi over the length cubed. That's the length of your rod over 3. And I'm not going to go through that because I'm running a little late here. I'm going to have to pick speed up. But if you were to ground your rods together, say from your antenna to your wherever your circuit breaker box, and we normally buy 8-foot ground rods, you could space those ground rods 16 feet apart, and you would get adequate ground coverage. Now, if you get them too close, you're wasting space, or if you go too far, you might have a little resistance potential between the two. But for 8-foot rods, you could space them 16 feet apart. It would give you ample coverage. Okay, ways to tie it to safety ground. Okay, using your sphere of influence measurements, which, when possible, your copper rods use the largest AWG wire possible. Ground to ground connections use at least a number 6 gauge wire when you're working outside. Now, once you get inside the shack, you can use a a lesser gauge for equipment to equipment, but you need to use at least a number 6 on the outside. Copper wire, has resistance, and the ones that we tend to talk about is the 6 gauge is what you want to use outside, and you can use up to 10 gauge inside. If you go smaller, well, then the smaller the wire, the more resistance it's going to have. So 10 gauge inside is probably about as small as you want to go. Now, I highlighted the quad alt wire for one particular reason. Is that's probably the largest wire that you can get, and its diameter is only half an inch, less than half an inch, 0.46 inches. And I want to show you something about how electricity, well, you know how electricity flows. DC flows through the body of the core of the conductor, and AC flows on the outside skin of the conductor. Well, when you're grounding, you're talking about AC. This could be lightning, it could be static discharge. It's going to be an AC component. Now, it doesn't mean 110 volts AC. It just means it is an AC type voltage, and it's going to travel on the surface of whatever conductor you're using. Excuse me. Let me give me a little drink of water. And they always suggest that if you use stranded wire versus copper wire, you get greater surface area because stranded wire would have 8 or 10 strands, and the skin effect, the current travels on the outside surface of each of those little wires. Or if it's a solid wire, it travels on the outside of the larger diameter. Now, one thing that people don't really consider that, well, if it travels on the outside, I could actually, inside my shack, I could use copper tubing as a conductor. And let's look at some. Well, this is the math. I'm going to skip the mathematics in there because I'm starting to run out of time. But if you use copper wire, like on the back of your table where all your equipment is, a copper wire, half-inch copper wire, has a greater surface area than quad alt wire. It's like I forget what the diameter is, but it gives you more surface area. And what I have done, now this is a mock-up of my particular station. If you look on the left, I've got a Siglink, a Cantronics, I've got a Yaesu FM radio, a Kenwood, a speaker, and my HF rig. And if you look at that yellow line, that represents a half-inch copper bar. Each of those little clips that you see are copper clips that you can, here again, you can purchase them at Lowe's or Home Depot. So the actual running line through all of that equipment on the side, the longest wire is probably 10 inches. I think it's about 10 or 12 inches. Same thing on the right-hand side. All of the connectors are very short. So I'm depending on that copper bar to be my center point of connectivity. And then that center bar is connected with a number 6 gauge wire that goes outside the room. I have just a hole in the wall that goes outside and goes to ground. So this gives me an adequate ground. So everything I have in my shack is grounded. Even my computer cases are grounded. You can go to the back of your computer case and lift up a screw and put a ground wire and run that to ground. Okay, let's talk about real world grounding systems. Well, ground loops, microphone bites, the RF shocks, the crazy RF, the PC jitters and all comes from the fact that a lot of times people have multiple grounds. They've got a main ground rod, they've got an antenna ground rod, their TV is a ground rod, but all of these need to be tied together. They connect them all to a common point. Now this slide may be a little busy, and we're going to try to step through it pretty quick. This is how, if you were to take a snapshot of the typical amateur house, you've got your circuit breaker box on the left. You got your transceiver, an amplifier, power supply, computer monitor, and everything is all wired up together. Okay. Okay. This green wire, this represents the house ground. This is your safety ground. This common ground here, this is the one that connects all the metallic surfaces in your shack to ground. Okay, here's a chassis ground that's connecting your power supply to your amplifier. Remember that's a DC, and usually that black wire is a ground wire. Okay, and then there's your coax. Your coax is grounded from your transceiver to your amplifier, and it goes from your amplifier. It goes out to a coax, usually to a DC discharge for lightning protection, and then that's connected to ground. Okay, and then we've got our signal ground, which is a little purple wire from your USB cable. Basically, has a floating ground that goes from your transceiver, if your computer control, back and forth. So this is how your system works, and the important point in this drawing is right here. This is where everything ties together. This makes everything at the same potential. This is what keeps you from getting shocked, and this is what prevents your TV from flickering when you're transmitting, or it keeps the lights from flickering. If you can get everything tied to one point, then you're good. Things not to do. Of course, don't connect your chassis ground to your house ground without bonding a system. Tie it all together. Don't connect a vertical counterpoise, the other half of your vertical antenna, to your house ground. Won't work. I tell you, and you'll get RF back into your house. Why? Both of these conditions will cause RF to enter the house through your house ground. And remember the pop quiz about that? What is it? Well, you know what the NEC stands for and who your AHJ. That's your building inspector. And this point of single point grounding. Well, I think I've mentioned that probably enough times. Is it safe to have a safety ground for your ham shack? Well, you don't need a separate ground. All grounds must be bonded together. Does your TV flicker when you key? Well, here again, if you get your grounding fixed right, that'll go away. Is bonding different from grounding? Yes, they are different from grounding. The terminology is different. Should all antennas be grounded? Not necessarily. That's not true. Is it okay to connect all grounds to your house ground? Absolutely yes. That is an absolute yes. Microphone bites you, does you crazy things, so on and so forth. Well, we've going through this thing. If you can do what I've tried to show you about tying everything together, these will all disappear. All these problems should just go away. We talked to, we've compared bonding versus grounding. I did a little bit of talk about your electrical safety grounding, chassis ground, not RF ground, and your signal point grounding system. And this presentation, if you want to go download it, it's out on our website. You can go pick it up on k5lrk.com. Just click on the presentations tab. I got a whole bunch of presentations out there, but just go down till you find the one on bonding and grounding, and you'll find two of them. This is actually part one. I think Ken Mitchell will be doing part two for y'all. I think next month or so. But I want to appreciate you for letting me come in the last minute. It was kind of a quick decision for me to do this, so I hope everybody got a little bit out of it. In this presentation, there's a ton of references. I mean, there's pages of references that you can go through and all, and I will stop sharing. All right, David, I'm giving it back to you because
Okay.
I need to boogie. I've got my CW class coming up here in about 10 minutes. I got to get ready for that.
All right, Ken, normally we'd have you answer some questions, but we know you need to to move along. So
Well, like if anybody's got anything that they want to ask, you know, I've got a minute or two if there's got a burning question.
okay. First in the room, anybody?
I just want to say thank you for
Yeah.
being here.
Liz says thank you very much, Ken. Of
Oh, you're
course.
welcome.
And yeah,
Yeah, Liz,
sure.
we've talked a couple of times, Liz.
Daryl.
I have two grounding systems. We have the ground system that the house has, which is an 8-foot pole, copper thing in the ground connected to the circuit breaker box. But when I put my ham shack in, I ran my own poles separately, and all my antenna systems and chassis and everything are grounded to those outside ground poles in the ground. But they're separate from the house ground by about 20 feet. Should I connect them?
Yes, absolutely. Your system ground, your antenna grounds. If an inspector were to come out and see that you had two separate grounds, that's not good. For safety reasons, all your grounds should be connected together.
Okay.
All of them should be. Now, what you can do is measure the distance from that particular ground rod to your house ground rod. And if you use the 8-inch rods, remember every 16 feet, so you wouldn't, and I'm not sure what the distance is, you wouldn't have to go too many rods.
So I could actually put another 4 or 5 foot, 6 foot rod in between the distances, and that would basically cross connect everything.
Yes, you could.
Okay.
Yeah.
All right.
Some of us that have verticals in the backyard, if they're like 40 or 50 feet away, we've got a big problem. Lots of rods. That's right. And lots of number 6 wire.
Lots of number 6.
Okay.
Yep.
Anybody?
The reason for number 6, it has less resistance per
Right.
1,000 feet, and that's the whole purpose of it. All right,
Any of-
gentlemen.
Any of the Zoomers? Last call for questions. All right. Well, Ken, I'll let you go do your da stuff.
Yeah, if anybody in your club is interested in maybe learning to dot it up, Ken Mitchell and I, we do a CW presentation. Also, I do one on the history of Morse code, and then Ken Mitchell picks it up and does a little bit more locally. So you guys have a great evening.
Thank you,
And
sir.
dotty
See-
da.
CW is the original digital mode. Go off and make it happen. Thank you. But
Yeah, okay.
thank you, Ken.
You're welcome.
73 as always.